Okay, so we can upload the file over here through selecting upload. However, Fusion has a insert tool over here where we can insert SVGs, DXFs, and this is kind of the preferred method for OBJs and STL files. So I'm going to insert mesh over here, equal that we're going to carve out. And as that imports, here it is. We can orient it the way we want, but I believe it, yes, it comes in default top up. That's kind of the way I want it to fit on my board. This can be manipulated later on in the machining area. We can also set some measurements here. I need to change that document size in just a moment, but I'm going to go ahead and leave it the way it is. Import the file and change this from metric over to imperial real quick. So here we've got the model, and you can, my board is 10.5 inches by tall by about 10 inches wide and a little under 3/4 inch in thickness. It's a 1 by scrap piece of wood I'm going to carve this out of. So over here I show 13.6 inches as my size, but that wasn't too accurate. If you noticed, the tops of my wings are actually higher than the head is going in a diagonal line. So this measurement's a little inaccurate, and it's going to be difficult to get that Z measurement as well. So what I'm going to do over here is we've imported the file, going to jump into the manufacturing environment and set up some cam settings in here. And since I've measured all this stuff in inches, I'm going to go ahead and change that units of measure over. In my defense, I work at a company that does metric and imperial, so I end up using metric for my feeds and speeds, but my tape measures aren't metric, so I measure the board in inches. So just converted that back over real quick, and we'll run through it that way. I might have to do a few other conversions during this tutorial, but you'll get the gist of it. So I've created a setup, which is essentially I'm telling the cam how big my material is to carve this shape out of. And what it does over here is it also offsets the side and top by default. So I've zeroed those out. And that tells me that my actual dimensions of my mesh here are 13.744 inches by 10.89. And what I want is to fit that 13.74 in 10.5. So I'm going to divide 10.5. And honestly, it's about 10.6. It's just under 10 3/4. So if I get in 10.5, then I'm fine. So I'll do that, and that tells me the multiplier that I want to scale it by is 0.7639. So we'll go with 0.76. So it's just a little bit under that 10.5 when we jump back in here. And if it matters precisely what your size is, you would use this cut down even more, so 0.763969, and that's probably close enough detail to get it almost right at 10.5 for your specific size carve. To make it easy enough, we could actually just copy this out of here and use that number. And so now our setup is in there. I'm just going to save that so we can go back in this design space, and we want to scale it. The issue is if we try and scale it up here, this is the scale function for a solid body, but this is not a solid body, it's a mesh. So we're actually going to go over here and click Edit, which opens this mesh design space, and there's an icon that looks identical, but it's going to scale the mesh. And you can just select it here or select here as well. And I'm going to paste in that value that I copied over. Control V, paste that in there. And now I've scaled it down. And now that I've finished that, I'm going to close out, X out of that mesh, kind of saves that mesh change. Go back into this manufacturing. Check my setup here. And you'll see that I'm down to 10.5. However, my Z height is 0.76, and after surfacing this board that was severely cupped, I know it's at 0.61, so I want to change that Z height as well. So I'm going to do the same sort of thing I did with the Y, but I'm not going to scale it uniformly. I'm going to leave the X and Y alone and only scale the Z, which is actually going to cause a little bit of loss in the depth detail as the bit goes over it. But that's how big my board is, so I guess I'm willing to sacrifice that right now. There's some other tricks to moving the mesh up and down, essentially, in this stock. If you have space to retain your original detail while kind of cutting it thinner. But with these effects like the wings here, and they get pretty thin at the edges, I don't really want to risk these guys being too thin and just snapping off during the cut, or when I have to peel it up from where it's taped down to. So I'm going to do the same thing here. I measured 0.62 when I measured it, but I want to make sure that, like I said, I didn't measure it incorrectly. I couldn't get directly to the center to measure it. I measured it from the edges where it was cupped most at. So we'll go with 0.61 divided by 0.761488. That tells me I need to scale it down by this amount, 0.801. So now that I know that, I can jump right back to where I was in this design space. The mesh body is right here still. I'm not in the mesh workspace anymore, so we'll do this one more time. Edit, modify, and scale. And I would change this to non-uniform. And once I select the body, this will pop up here, and I want to only scale the Z by that amount. And you can see what just happened there is it'll change the detail. And if I do it to 0.2, I lose so much detail, right? Because it's now less than 1/4 inch thick. So actually less than 1/10 of an inch thick, basically, because I'm scaling it 0.2 of what it was before. So scaling it by that factor, 0.801. Go ahead and do that now and approve that change. Go back into this manufacturing environment and verify this setup one more time. I'm at 10.5 by 8.3. That's within my X and Y, and my Z is right at 0.61. So I'm safely within the 0.62 that I measured, but I measured that on this edge and that edge where it cups the most. So it might dip down a little bit in the middle. So just to make sure, 0.61 is my Z height there. And so the next step is to start doing the CAM process to carve this out. And for our roughing pass, there's a few ways to do it. I prefer these two clearing tools on top. Adaptive will take a little bit longer to compute, but will carve it out a little bit faster. And having done this already, I know it's about 2 minutes of carve time difference and about 10 minutes of computing time difference. So I'm going to go ahead and do the pocket one, which computes a little faster. So the first thing that pops up over here, you get this window similar to the setup off to the side where we're going to set up our cam. And we're going to do that by selecting the appropriate tool. And by default, it pops up with the custom ones I've made. And this taper bit is what I'm going to use for detail. So now for roughing, I'm going to select one of these samples. And for what size board this is and what material I need to take off, I know that this 4mm flat end mill is one of my go-to favorites. It's an upcut 4 flute that I have on there, but I know this default one is not set to the correct number of flutes. That's fine. You can change all the settings in there for those tools. I have not done that yet. Additionally, so as a result of that, my feed rates are not optimal for my machine. So I know my machine can cut significantly faster than this, especially during this roughing pass. So I'm going to go ahead and set all these feed rates to about half what my max speed is, because you'll see later on the program I used to run it, I can scale the speed up and down up to double whatever it was set up to in the cam. So 180 inches per minute is about half my max feed rate in the X and Y, and the Z is set to about half that. So I leave those down here set to 90. And the ramp and the plunge are essentially the same. This is the as it engages, so you could set it to engage when the material is slower. And then if you're going in a direct path up and down for engagement, you can set that as well to a different speed. But I leave those all set to the same. So the next step over here is to select my containment of the tool. And what this does is if I leave it a bounding box, it's going to try and remove all of that stock material from that square I set up. And I don't really want that. What I want to do is more of that silhouette pattern that you see in the center down there, where it follows the contour shape. So I'm going to select silhouette. And my step down here, I know that this tool can go at 0.08 without an issue. So I'm going to leave it at that for my step down. My stock to leave 0.02, which is going to, I'll show you on this pop-up, leave material behind in these two directions, which ensures I don't have too much chip out. And my finishing pass can remove that little bit of material that's left behind. If I was to take this to 0, there's a possibility that I could, if I took either one of these to 0, there's a possibility that I could chip out just a little bit of material, which then is apparent in the finish after the final pass. So I like to leave some stock to leave there. And then I'm going to come over here and verify these are set correctly. Now, one of the things that I like to do here in the software is change this maximum stay down. You notice that those yellow movements are the tool lifting fairly often, and those are essentially wasted movements. So I'm going to change that to be a lot, and just some random high number, so that it stays down as much as possible. And that's about all I need to do here. You can change the ramping, the way it ramps into material here, whether it plunges straight down, does a zigzag motion. This helix works just fine. To make it dig in a little faster and not spend so much time going around, I typically change that. And the ramp clearance height, I'll drop that down a little bit as well. So basically it's going to start the ramp, this spiraling motion, at more steep of a spiral, and by changing the clearance height at less high up. So it's going to make it still going to do a spiral motion, but it's not going to be doing it so much in the air now that I've reduced this clearance height. So it's going to make it carve a little faster. The other thing I need to do here is change this retraction policy to meet what my Z height is. So my Z height can't go too much higher than 0.04 from the top of the material. So I'm going to keep it at that. I could probably double that and it'll be safe. So I like 0.04 from where it's at. Because of the way I have my machine set up, I don't have a lot of Z clearance, but it works fine for running one by material where it's at right now. So once that has loaded, I can click on this little eye here and it's going to view it. And that's going to show in blue my cam path that we've just created. You'll notice if I select top here that the tool is just barely, this is center line of the tool here is this blue mark. And it's barely going to go around and cut the edge. And I don't really want my tapered ball bit when it comes down here, which is only a 0.5 millimeter diameter thickness at the tip, to engage in a lot of extra material around the outside. So I'm going to go back and edit this one more time real quick. And it's also leaving a lot of stock down below that as it comes down over the edge, right? So I'm going to go ahead and edit this tool path real quick and change this to offset this by just a little bit. So that's going to make it go slightly outside of the predetermined boundary. Okay? And it's going to generate the toolpath one more time. And once it finishes generating, we'll get to preview what that toolpath looks like. So now what we've done is made it so it can go outside of the boundary, the thickness of the tool, in fact, twice over. So I don't really need to go that far outside the boundary, but we're talking a 17-minute carve here. I could shrink that down a little bit so it only goes one tool spacing, but just to make sure it doesn't engage this material here, I kind of like it the way it is. However, it's going so deep now that it's actually going to cut the material out. It's going to cut my shape out in this one tool pass, or come extremely close to it. So I'm actually going to lift the bottom of this tool pass up just a little bit by setting this model bottom in here by -0.1. So we'll go 0.05 inches. And that's going to do is lift that final pass, and we'll see once it calculates one more time, we'll have a little bit thicker material left. A little bit thicker over here on the side. Not the full height that it was before, but it'll be a nice, safe thickness so it doesn't cut out. And also you'll notice that some of this mesh has shows a different color. The pink is that, oops, negative was the wrong direction. So the negative is going to do a full cutout. So if I would have read that pop-up there, I would have realized that I need this to be a positive number. And that's going to lift it just a little bit off the side there. So as I was saying, the mesh here shows pink for a mesh and this golden color for a surface. Still not a solid body because there are holes in it, but it can better turn a surface into a solid body than a mesh. But that's why you kind of see these different colors here. So somebody must have used a mesh mixer on this file before I got it to use it for 3D printing, which that's fine. That's how you're going to find a lot of your files. They'll be either pink or a combination of this pink and gold. So now we're at a 16-minute, 59-second, so 17-minute roughing pass here. And by what I did there and changing that height, you'll see I've now got a little bit of thickness there in that material. Not as much as it was before I went outside the boundaries, and also going outside the boundaries cut down on this super tall stock that's next to it. So I can either run this through a simulation, which is right here, and we can play this through. I'll speed it up a little bit so you don't have to watch. As you speed it up, it does kind of jump around. And if you want to run this faster, you can change the way it shows over here. This is 3-axis CNC, so I don't need to worry about the other 4th and 5th axes that this program can calculate and display. So I've essentially dumbed down the preview to this fast version, which allows it to not stutter as much as it would if you leave that on standard. So by doing that, I can actually increase the quality and keep the quality at extreme without it getting hung up or freezing during this playback. So I've played it back here. If there's a collision error, such as the machine is set up, the cam was set up to put the tool or the tool holder into the stock at a high rate of speed and basically crash it, you'll get a red pop-up. And if you select actually, let's see what this warning is real quick before I get too far. One or more pockets were not machined because they were too small. That's fine. So my pocket's too small for the bit to fit in. I'm not too worried about that. So let's go back over here to this. Simulate real quick, and I'll show you one more trick in here. So after we simulated it, we'll jump through to the end. You can use this button here to go to the end of the path, and you can see the stock that it cut out, which this kind of shows the same way as that previous one did, but if I now want to jump to any portion of this, you can drag the timeline bar down here of the carve, basically see what it's going to do. And then again, in here you can verify the distance of this carve is 251 feet. And that's how much it's going to move that bit around throughout this process. And my machine time, as before, 16 minutes and 59 seconds. So now we've created the roughing pass. If you're happy with that, you can actually run this while you do the next part, which is create the finishing pass. And it can be done in a few different tools here. I prefer either the parallel or the scallop. What the scallop would do is start at the center point and carve it from a center point in a circular-like motion towards the outside. And that's a pretty neat reveal of the part if you're going to record it and play the video back. Or the parallel cut as well just basically does stripes back and forth, which is less essentially I'm going to just go back and forth on the x-axis, and the y-axis will slowly step up. And I clicked the wrong one. So we'll go back there real quick and select parallel. So in the parallel tool, I'm going to not use that 4mm flat end mill. I'm going to use a taper bit here, which is kind of like a cone-shaped bit, but it has a very small 0.5 mm diameter ball on the end. And I've created this tool myself in Fusion, but this is a tool I purchased off of Amazon for $20 for a 4-pack, I want to say. And I've yet to break the first one, and I've been using it for a few months now. It's not worn out, and I haven't broken it, but I'm sure it is going to wear out eventually because I am essentially cutting dust with this, with these super fine passes. So I'm going to do the same thing here, is adjust that feed rate up. And my silhouette, again, is set like this, and I'm going to leave it tool outside the boundary, and you'll see that what that looks like here in this pop-up. So same as before, the tool is going to go right on the outside. And another thing I want to do here is, if I leave this disabled, it's not going to get all the way over to the very edge, and I want it to. So I'm going to enable this tool point or contact point boundary, and come back in here, set these to that same retraction height I had before. And then my step over here is, so my tool is 0.5 mm. Or 0.019, and I like to go about 1/10 of that as my step over here. So I'm going to change this to 0.002, a little bit over 1/10 of the size of that bit, because the diameter of the ball, it was that 0.019. So my engaged surface to make a flat, if I'm going to do pass over pass over pass, if you don't mind the ridges showing, you can use a larger step over, but it is going to show those steps as lines in the toolpath, which is going to drastically speed up your machining time, but it will show those marks depending on the size of your bit. So I like to go about 1/10 the bit size for my step over when using a ball end bit like this. And my direction is set to both, so that's going to machine both directions, so it doesn't waste movement going back to the one side to cut that. It's doing super tiny passes, so it's not going to make that much of a difference. We'll leave this how it is. Safe distance, set that to the same thing it was back here. And my maximum stay down is going to be a lot again. See what that generates. I'm going to hide this roughing toolpath for now. and we'll see how long it takes for this parallel one to come up. It's doing a lot of super fine detail passes, so this can take up to 2 or 3 minutes to generate. So I'm probably going to speed this up. Hi, so what ended up happening is I realized as the toolpath was generating that I had used a positive number on that bottom height of that parallel path, and that was the positive number actually lifts it, and I need a negative number to make sure I'm cutting through. So I corrected that, and it's running again, and I'm going to simulate the toolpath one last time to show you guys how it cuts through the edge as soon as that's done generating, and I'll be back with you in just a quick second. So the toolpath is finished for that parallel, so I'm going to go in and simulate this carve, jump all the way to the end, and it's going to take a moment to generate this toolpath. But the big thing I'm looking for here is just this. All right, so see all the light we can see through here? That means that it is cutting through the stock. And as it finishes the generation of this simulation here, oh, it looks like it's done. Okay. What we see here is full cuts through the stock. It doesn't generate air that well, so the cut through doesn't show in too much detail, but it shows that you're cutting through the stock. And so it looks like the toolpath is good. Like I mentioned, these green exposed spots here are what was left from the cutting toolpath because of a taper. The taper bit being my file toolpath, so those are actually rough cuts that are left there in some small areas. But it's so small of an area that you're never going to notice when this carve comes out that there was some rough cut there. So what's next here is to export it now out into a G-code that the machine can run. So since we have two different tools here, I'm going to export as two different files, and I do that through this post process. Most of your G-code type G-code and the 𝐭𝐫𝐢𝐚 machines can use this same 𝐂𝐴 exporter. And this was really designed for X-carve, but it kind of works with it works well with the X-carve, 𝐁𝐿 𝐿𝐿 and my Workbee, as well as the 3018 behind me. They'll work fine with the same post processor. The issue is that the negative part about it is that the Fusion360 was recently kind of downgraded for free users, and the faster speeds when it's at the safe height, when it would normally transition at a fast speed, it no longer does that. So unless you have the paid version, pro version of Fusion360, using this post processor is going to make it take a little longer than it did in the past. I have other post processors that are more designed for my machine that eliminate that, and if you have those post processors, then you can do it that way. But the more universal way is this 𝐂𝐴 one, which the walkthrough of how to download and install that and set that up is on the Inventables website. Just, I think you search, I'll put a link in the description to how to get that post processor and install it. So what I'll do here is simply post, put it in my desktop. That's kind of the default file name is 1001, so I'll just leave it at that. Since I used a default tool, it throws the tool number in here, thinking that my machine has the ability to swap tools, and it doesn't. So this G-code will actually cause a error when you run it if you leave this tool in there, unless you have a machine that can do the automatic tool changes and you have tool 1 set up as your as your whatever you use for your roughing bit. So since I don't have that, I'm going to go ahead and just delete this line out and then save it. You can delete the whole line or just that bit of information. It doesn't really matter if there's a space in there or not. So like I said, save it, close this one out. So that is the roughing pass. I'm going to post-processing the finishing pass now. Head back into desktop here, and I didn't bother really labeling that first tool pass because I already have the bit installed, but I labeled this next one with the bit name as well, so I know which bit to run this pass with. And since that's a custom bit that I made, the tool number is not assigned, so there's nothing to delete out. I just save it. And now we can save this in Fusion. We'll save it as 𝐂𝐚𝐫 mesh, and that's going to take a moment to save. And once it saves, the asterisk will go away, indicating the file is saved. All right. It also has to upload the save file to the cloud storage, which is where all the Fusion files are saved. They're not actually saved on your computer. They're saved in the Fusion cloud, but it has saved a local version on my drive, and that's why the asterisk went away. But right now it's uploading it to that Fusion cloud. So now I can exit out of there, open my GCode Center, in which case I like the Open Builds one. And once it loads, I can just import that and run the code. I do have to set my zeros for X, Y, and Z, but you can see here that since we centered the lovely, since we centered the X and Y, I have marked the center of the material, so I know where to place that bit at afterwards. So I'm going to actually run the bit off to the side over here, zero it to my wasteboard, the Z height, and then bring X and Y over to the center that's marked and zero those out using this functionality over here. It's kind of neat in this program that you can zero all three independently instead of having to go to an X, Y, and Z zero. This program will also home the machine if you have home sensors set up. I have those on the machine, but since I got so used to using the smaller machine that doesn't have them, I just don't use them anymore. And I manually place my machine every time I run it. So now it's just time to run the code through either this one or your preferred GCode Center. And I'll just play a quick montage of it cutting and check back with you in a moment when it's all done. What I'm going to do here is my X and Y zero are set to the center of the material. I'll set that next. What I'm going to do now is set my Z zero to the top of the wasteboard. And I'll do that by toggling down until I hit the top of that. I do have a Z Pro, but I don't always use it. So it's actually unplugged and in a drawer right now, but I'm going to toggle the Z down. So this camera, which is a few feet away from my mic, so sorry about that, you can't hear me. But just going to toggle this down until it lightly grips the paper. And then I'll actually toggle it down one more just to make sure. And set this Z0. Raise it back up. safe height. And now I can run this G-code. I have to turn my spin. Actually, sorry. I have to go and set my X and Y zeros now that I've got my Z set properly. Because of where I'm at on this material, I don't have to have these set perfectly. But having them pretty close will help. So move to their appropriate locations, and then I will set the zeros right here. And now my Z has been set to the top of the wasteboard. Now it's been lifted 20 millimeters, and I have X and Y set to its current location. So now I can simply turn my spindle on and run the program. Just to make sure it runs right, I like to drop my feed rate down a little bit for the initial start of the run. And now I'm going to run the job, and we'll see how it goes.